So hello everyone and welcome to another video. This one's a pretty quick one because I gotta go in less than an hour. But yeah, so I want to show off something really cool today that I kinda knew the Elmo Labs EVC2 can do, but I never used it before and well, it's super easy to understand as you're gonna see, but I never tried to understand it. Anyway, so I've connected the EVC to one of my HD4550s. Now this is the first of several 4550s that I have coming my way. This one arrived, and I have another one from eBay coming in, and also another one that a subscriber of the channel actually offered to send me. So Pesky Plumbers, if you're watching this video, thank you very much for sending over your card. That's not this one though, because yeah, this is one of the eBay ones. Anyway, so this is a proper it is DDR3, like little G DDR3 memory. This one's got Samsung D-Die, yeah, so like you can see the artifacts, but it does clock 1100, which I guess is pretty okay, but that's not what the part is about. What it is about is that you can see our VCore voltage here. It's overvolted, quite heavily so, but these cards run cold enough so that's fine on air. And I have the EVC connected to it, but I'm not using any of the I2C headers. I'm using the SRC headers. And I'm only using 2 wires. And that's all the mods on this guy. You can see the back of the card is completely empty. The only other thing that's on it is the multimeter reading the voltage. So yeah, the EVC2 can also control, to a lesser extent than the I2C ones, but it can still control analog voltage controllers like the UP6101 little 8-pin IC that's on this card. And so the way how you implement this is literally, so the brown wire is soldered to the feedback pin of the controller. So you look up the data sheet for your controller, you find the feedback pin. On these little 8-pin things, the pins are big enough to solder directly to them. Otherwise, you just find an empty pad or capacitor or a resistor that's connected to the feedback pin and solder onto that. Keep in mind to solder onto the side that is connected to the feedback pin. Though I assume everyone who will actually take this information and use it does know that. So that's the brown wire. That one goes into the SRC pin. And then the red wire is connected to the output of the VRM. So anywhere where you have your voltage output. So in this case, it's on an empty pad connected to the output leg of the inductor. That one you connect to any of the V pins, so V1 here. And what that does, bandage actually finished now, and Adobe is doing something. Hey, that's a pretty good score actually. Yeah, so that was 1 GHz core and 1100 mem on the 4550. This one. So yeah, now let's go over to my daily system and look at the EVC software. So I'm here in this submenu, in the DAC submenu, and here you can see what I've done. So this part down here is not that important. That's just for reference. So like I've measured the resistance between feedback and output, and also feedback and ground. And then put in the voltage that I was measuring at the feedback pin. That just kind of gives you a suggestion of what your increase will do to the voltage. It's not really accurate. I was actually measuring 0.8 volts, and yeah, we're not at 1.935. So yeah, but anyway, so right here we can see what the 2 connected cables to the EVC do. So the red wire, the V1 wire, gives us this voltage reading right here. It's just measuring the voltage. And then this one, this drop-down menu, is what the brown cable does. That's connected to feedback. So the onboard DAC of the EVC can source or drain current from the feedback pin, which will change, effectively it does the same thing as a feedback mod, as a normal potentiometer, but just on the EVC. And you can see it can control up to 3 of these at the same time. So basically, if I now go to 0 and press apply, the card just crashed because it was still at 1 GHz, but yeah, now you can see it's at 1.1 again, which is the stock voltage for the card. And now if I go -10, press apply, we are at 1.2 volts. And then, yeah, 20, 1.3 volts, and then I had it at 40, which is 1.5 volts. So it does go in 100 megahertz steps, which is kind of a lot. It will depend on what resistance you have at your feedback pin, how precise this is. Like, I could set something that will immediately destroy the card. So, yeah. And also the cool thing is, you can't just, like, this is minus, this is taking current away, like draining current from the feedback pin. You can also add current to the feedback pin. And you can, now this is for sure gonna crash the card, whoop. You can lower the voltage too, so now it's at 700 millivolts. And to show you that it's not just simulated, yeah, that is our actual output now. So that's just really cool. Like, that is actually really cool. Yeah, I think the cards are coming back. I need to reset the system. But like, yeah, like that is super cool. You get a graph for your voltage and everything, and you just with the click of a button. And you even get like a little example of what it's probably gonna do. Then now you can see in my case it wasn't very accurate. But in yours it might be better. It also this works for a normal feedback mod, like this is the circuit you usually have for a feedback mod. It also works for a ref-in mod, which you do on newer cards, like the like basically 10 series, 20 and 30 series NVIDIA, where you mod the ref-in pin. Yeah, they just like they use. Actually, I'm not really sure where you solder it. I guess you solder it to ref in. Yeah, yeah, I guess you solder the brown wire to ref in instead of FB. And then the red wire to VREF instead of V out. Don't quote me on that though, I'm just using basic pattern recognition here. I've never done a ref in mod, and I don't really have any card that I'm willing to sacrifice for testing. Because the only cards I have are my 2080 Ti and my 1070. Both are cards that I need. But anyway, yeah, you can use the EVC2, the onboard DAC of the EVC2SX, and also the normal EVC2S and the normal EVC2 also support this, but they have a different DAC. I think they only support 2 or 1 channel instead of 3, and they have bigger steps. So yeah, and like these steps already kind of a bit big on this car, as you can like basically 100 millivolt steps, which would be fine for something like memory. For core, I would probably like to have 50, if possible even 25 millivolt steps. But I mean, for a cheap-ass card, this is fine. Like, I mean, you don't really need that precise voltage anyway. I mean, I'm planning to e-power the card that I'm actually gonna run for scores on cheap-ass. But, this is super cool. Like, I could do the same to memory voltage on the card, because that's the exact same, that's also UP6101. Like, I think that's really cool. I don't know why I haven't done this before. The only thing that and I just got a message on Discord. The only thing that I don't like that much about this is just that it adds like I mean, I just did it kinda in a stupid way. I soldered the cables directly to the card. What I should have done is probably like solder 2 wires to that, but then have like a header on the card that I plug the EVC into, and not just have the cables like permanently attached to the card. I should have like small cables on the card with a header, and then I plug the EVC cables into that. Because I also don't have that many EVC cables. So basically I'm committed to solder these back off of the card once I'm done using the mod on the card. But yeah, still, this is so cool. and so easy to do. I reckon this is actually easier to use than a normal FB mod, though the cost of entry of like an EVC2SX, like it's $32, is maybe a bit too high for people to actually consider this, because just buying potentiometers is a lot cheaper. So your first volt mod should probably still be on a potentiometer, unless you're like super committed to extreme overclocking and you just want to have one of these anyway. Like EVCs are super cool. They have I2C, they can flash your BIOS chip, and they can do this. Overvolt and undervolt for feedback and reference. Yeah, so that's what I wanted to make a video about. So thank you all for watching. I'm going to go to my parents in not long, and help my grandma move to a new place. So I won't be there over the weekend, so I'm probably not gonna be doing that much stuff, but when I'm back I will probably have more graphics cards waiting for me. And then we can get down to business with the 4550s, which I will hopefully get all three of soon. So yeah, thank you for watching, hope you enjoyed. I hope you're excited about this feature as I am, because I think I'm gonna use this a lot in the future, because it's just so simple to set up. It is so simple to set up. So yeah, I really like this feature. I'm really excited. Anyway, video's over now. Bye.